Hello and welcome back. We're going to continue seeing math, and like I said, those videos are going to show some details in math which I think sometimes they are overlooked and people don't pay attention to some details and they just starting to say wrong names to the wrong parts of the math operations. And we have names, right? And if we have names, let's just name correctly each part of those numbers. Okay, so before I continue, let's just go back to paper and let's see what's going on. Now, we have in the addition, we have terms. In subtraction, we also have terms. And in the multiplication, we also have terms. In here, I'm not going to talk about it because it's in a different way, okay? I'm writing equalities in here. Why equalities? Because it has an equal signal, can you see? In here, I don't have an equality per se because I'm writing a different way. But let's just see those three first. This is an equality. What is an equality? 5 plus 7 equals 12. This is an equality. Now, this equality has this expression 5 plus 7. So 5 plus 7 alone is called an expression with two terms. Now, let's see this one. 15 minus 6 is also an expression, and that expression also has two terms. Now, let's see this one. This is also an expression, and this expression has only one term. And I say, I don't understand. Why come we have two terms in here and one term here? Because we have two numbers, two terms, and now one term? Yes. Why? Because when numbers are being multiplied or divided by, they are just glued together, and they say, this is just one term. But when they are separated by pluses or minuses, then we have two terms. So a term is nothing else than part of the expression separated by pluses or minuses. Just that. Simple, isn't it? Now, when you're talking about addition, those terms are called the addends. So 5 is an addend and 7 is another addend. So we can say that addition are formed from several addends, and all of those addends, when they are just summed up, they are going to give us the sum. When you go to subtraction, we can also say that when we have the minuend minus the subtrahend, we are going to get the difference between those numbers. And as a matter of fact, if we just put it here, put blue is good. If we just put the number line in here, and if this is 6, and let me see if I can write, because sometimes I have, I cannot write in here, you see, because I have this paper in here. Now I can. Because if you know my classes, I also use this one under, because those pens, look, they just mark everything. Now, while this is 6, and this is 15, when we say 15 minus 6, this is the difference, right? The difference. Okay, so the difference, it's how far are them apart. So the farther one is going to be the minuends. The closest one to the 0 is going to be the subtrahend. So terms in subtraction are called minuend and subtrahend. Terms in addition are just called addends. The final answer for addition is called the sum. The final answer for the subtraction is called the difference. The final answer for the multiplication is called the product. Okay? Now, let's just take this example here. 7a plus 2 equals 4. This is an equality. In this equality, the right side has one term. The left side has two terms, being the 2 and 7a. 7a, it composes only one term. Why? Because 7 and 8 are being multiplied the same way that 7 and 4 are also being multiplied. So you see, when you multiply numbers, they become only one term. But because they are being multiplied, we call this a factor and another factor. We have to distinguish them, right? So that term has two factors, okay? That term 7a has also two factors, 7 and 8. Did I forget something? I don't think so. Okay, so I just wrote in this one. So when you just write the subtraction in this manner, the minuend is going to be the top one, the subtrahend is going to be the lower one, the difference is going to be the last one. Now, let's go to division. The time, okay, 5 minutes. I don't want the video to be too long, but it's difficult to keep the short video if I want to explain everything. Now, division, we have the dividend, then the divisor, then the quotient, and then the remainder, okay? And for those that are not very familiarized with the division names, well, let me tell you something. You start by the divisor. This is pretty obvious. Why? Because 20 divided by 5 is 4. So the 5, clearly, it is a divisor, isn't it? Because 20 is being divided by 5. So 5 has no other way, and it can't be called any other name because 5, it is a divisor. Now, the quotient, it is the answer because it's the ratio between those two, the quotient. Then the remainder is just what is left, and the dividend is the one you're going to start to divide by. So if you want to memorize, one tip I can give you is this: just say it pretty fast and very often. Dividend, divisor, quotient, remainder. Dividend, divisor, quotient, remainder. Dividend, divisor, quotient, remainder. If you repeat very often this, chances are that you're going to get used to the sounds and you're not going to miss again. Now, once this is said, now this is the most important part of this class, which is going to be around the remainder. The remainder is the one that I'm most interested in this class, but I just had the opportunity to revise all the names. Now, the remainder is the topic of this class. Remainder. What's the remainder? What? Yes, so let's just say remainder. I was going to write something else, but let's stick with the remainder because that's how I started the video. So the remainder. So the remainder might represent an integer, might represent or a decimal like a tenth, a hundredth, or a thousandth, or whatever. Let's start with a simple case. Let's start, for instance, with maybe 57 divided by 7, something simple. Well, 57 divided by 7 is going to be what? 8, right? 8. 8 times 7 is going to be 56, to 57, 1. So far, I'm going to stop right away. I'm going to get more complicated, but let's start simple. Let's check. 57 must be equal to the divisor multiplied by the quotient plus the remainder, which is 1. Let's check if it's correct. 7 times 8 is just 56, and 56 plus 1, it is 57. Good, as expected. Let me just put the names in here. So this is the remainder. Okay, then this one is going to be the 8, the quotient, right? The quotient. This one is going to be the divisor, right? Divided by 7, divisor. And this one is going to be the dividend. Okay, so just remind the names. Now let's take something a little bit more messy. Now, And again, I'm going to put again for you, yes, this is the remainder from this integer, okay? Now, let's have another example in here. Maybe it's going to be now 97 divided by 7. 7 is a good number to divide by, or even 3. It could be 3. Let's put 3. Okay, now 9 divided by 3 is 3. 3 times 3 is 9. 2 9, nothing. Some people say minus 9 and then put the line and do the subtraction. I don't think it's necessary to do this. I never teach my students to do that. Why? Because you are just wasting your time. Because look, 3 times 3 is 9. 9 to 9 is nothing. So you don't have to write minus 9 in here. You are just wasting your time because you are not going to forget that's minus 9. So you are just interested in the remainder. That is the only thing that's important. So why to put more garbage? I would say it's not necessary. Okay, it's in math. The more concise, but having all it's necessary, that's what it takes. So 3 times 3 is 9. 2 9, nothing. So 7 goes down. 7 divided by 3 is 2. 2 times 3 is 6. 2 7 1. Okay, so far good. But now I'm going to go to the decimals, right? Put the comma, right, or the point, depends where you are. Usually we just put a point in here and a 0 in here. 10 divided by 3 is 3. 3 times 3 is 9. 2 10 1. Now let's stop and let's see what's going on in here. So let's check. 97 should be equal to 3 times 32.3 plus the remainder. And now let me ask you something. What is the remainder? 1? No, it's not. If you said 1, it's wrong. And then I'm going to prove you why is it so. Well, what is let's multiply this. 3 times 3 is 9. The dot in here. 2 times 3 is 6. 3 times 3 is 9. Okay. So far, we are pretty close to 97. If we add one more, it's going to go beyond 97, and it's going to be wrong. Now, let me tell you something. This is the remainder. It is. I'm not going to lie to you. Remainder. This is an A. Sorry. So this is the remainder. But this is the remainder of that number. And that number, it is not an integer. That number, it is a tenth. Isn't it? That number, it is a tenth. So it's going to be the remainder. Yes, it will. But it is going to be the remainder of a tenth. And the remainder of a tenth, we just write like this. And now, if we just add this one with this, we are going to get 97.0. So just be careful. And that is the whole idea about making this video, is to call your attention that we just have to be careful. What does it mean, the remainder? It can represent several things. Let's, for instance, do the same thing in here. 97 divided by 4, by 3 again. So 9 by 3 is 3. 3 times 3, 9. 2 9, nothing. 7 goes down. 7 by 3 is 2. 2 times 3 is 6. 2 7 1. The point 0. 10 by 3 is 3. 3 times 3 is 9. 2 10 1. Let's go further. Now 10, every time we need to go further, we just have to add a 0. Some people say, oh, but every time I add a 0, should I add a point? Of course not. The first point we just had to put because we had to separate integers from decimals. Now we don't have to put points anymore because it's already within the decimals. Now, since we want to go to another decimal, another 0, 10 divided by 3 is 3. 3 times 3, 9, 2, 10, 1. Let's stop in here. Again, let me ask you, is this the remainder? Yes, it is. But this is the remainder of this number, isn't it? It is. Why? Because look, that 1 came from this 3, isn't it? 3 times 3, 9, to 10, 1. That 1 is what is left from the multiplication of the hundredth by 3. Okay? So we are talking about hundredths in here. Hundredths. Okay? We are talking about hundredths in here. So, and just to close the video, is it okay? Yes. Now, just to close the video, 97 is going to be 3 times 32.33 plus the remainder. But now pay attention, we are at the second decimal place. We are at the hundredths, isn't it? So our remainder is going to express exactly this, is going to express the hundredths. And it's this part, so it must be that. Now, let's just see what is this. Well, I have to prove everything. So 3 times 3 is 9. 3 times 3 is another 9. Put the dot. 3 times 2 is 6. 3 times 3 is 9. You see? That's what we have. Plus the hundredth remainder. This is going to give us 9700. So what I want you to remember, it is this. The remainder can represent an integer if it is the leftover of that integer. It could be a tenth if is the leftover of this tenth. It could be a hundredth if is the leftovers of this hundredth. So you see, the remainder is going to be the leftover of the last digit that you are working with. Okay, that's it. That's the only thing that I would like you to remember. Just be careful about how dealing with remainders. Okay, so I hope I have make you increase a little bit your knowledge. If not, well, at least thank you for watching. And those are basic videos because some people, they just miss it, the basic things in math, and they start to get complicated during math classes because the teacher is saying something and they don't understand. So that is why I always say the base of math must be very solid. The base of math, those first 3 years in math, 4 years in math, you have to acquire a huge amount of knowledge, and you can't forget that, and it must be well given and well passed to you. Otherwise, you're going to not get along very well with math. So I just hope I could help a little bit. Thank you very much, and see you next video. Bye bye.